Hey guys, for today's e-learning video, we're going to review surface area of prisms and surface area of cylinders. So that's sections 9.1 and 9.3. And so just a reminder that your 9.1 homework is due Thursday by 2:30, and that your 9.3 homework is due Friday, and that we have a quiz on Friday as well over surface area of prisms and cylinders. So we're going to review today. We're also going to review tomorrow with a worksheet. But for right now, what I'm actually going to look at to start with is the last question from your 9.3 notes, which was a homework question, number 17 from 9.3. So we're going to look at this together. And then I'm going to do some other examples with you from just some examples of prisms and cylinders as well. So number 17 says, the cut wedge represents 1/8 of the cheese. Okay, so this piece right here represents 1/8 of the entire wheel of cheese. Find the surface area of the cheese before it's cut in terms of pi and round its nearest whole number. And as a in terms of pi, round its nearest whole number, so a whole number times pi. That's kind of confusing. And then it says, as a decimal, round its nearest tenth. So it wants us for part A to pretend that that chunk of cheese is still in there and find the total surface area. So if that piece of cheese was still in there, then this is just a regular cylinder. So to find the area of that cylinder, surface area of that cylinder, I know that it's 2 circles. Okay. And to find the area of the top and bottom circle, it's going to be pi times the radius squared. So again, I'm pretending that piece of cheese is still there. The radius of the circle is 3. And so if I do pi times 3 squared and then double that, I'll have the top and bottom surface area. Then I have this lateral rectangle, and it's very skinny. It's only 1 inch, but it wraps all the way around that cheese wheel. And so it's pretty long. Okay. And that rectangle is as long as the circle is round. So I need to know the circumference of that circle. Well, the circumference of the circle is pi times diameter, which is going to be pi times 6. And then it is 1 for the width. So this is 6 pi. And then it's only 1 inch tall. So 6 pi times 1 is going to give me the area of my rectangle. So 6 pi times 1 is this. And then the 2 times pi times 3 squared is going to give me my top and bottom circle. Okay, let's get you out of the way. 3 squared is 9, and 9 times 2 is 18. 6 times 1 is 6. So I've got 18 pi and 6 pi, and I'm going to add them together, and 18 and 6 is going to make 24 pi. Okay, so when it says to write your answer in terms of pi, the total surface area of that cheese cylinder is 24 pi. Then it wants us to round it to the nearest tenth, it says. And so I'm going to use my calculator, and this is where I'm going to use 24 and then multiply by 3.14. And I get 75.36. Now remember, I have to round to the nearest tenth. And so that means 1 decimal place. So I don't want the 6, but the 6 is big enough to round that 3 up to a 4. So this is actually going to be closer to 75.4 inches squared. Okay. All right. Part B. Find the surface area of the remaining cheese after the wedge is removed. Round the estimated portion of your answer to the nearest whole number. So I'm going to round this one to the nearest whole number, it says. Okay. So I'm taking out the piece of cheese. Well, what's important is it says the piece of cheese was 1/8 of the circle. Okay. So here's what that means. If 1/8 of the circle is missing, then I have 7/8 of the circle remaining. So basically I could do this all over again. And without this piece, with this 1/8 gone, I would be doing 7/8 of this and then 7/8 of this. Because if I take that chunk out of the circle, Not only is it out of the top circle, but it's also out of the bottom circle. And because this part represents 1/8 of the circle as well, this outside part, my lateral rectangle that I drew earlier, my lateral rectangle, it's going to have a chunk that's missing as well. So it's only going to be 7/8 as long as well. So if I'm taking 7/8 out of this chunk here, and I'm taking 7/8 out of this chunk here, I'm really just taking 7/8 out of the whole thing. Okay, so there's a really easy way I can do this. My answer in terms of pi, remember, was 24 pi. I'm going to find 7/8 of that. Again, if you're wondering, why does he keep saying 7/8? 1/8 of the circle's missing, so 7/8 of it is still there. Okay, so I'm going to find what 7/8 of my answer is, and I'm going to turn 24 pi into a fraction. The reason I'm going to turn it into a fraction is because if I multiply fractions, 7/8 times 24 over 1, I can cancel the 24 and the 8. Think what number goes into both of those. The 2 goes in, 4 goes in, but the largest number that goes in is 8. 8 goes into itself once, and 8 goes into 24 3 times. And so if 1/8 of the circle's missing, that's going to be equal to, or approximately equal to, 21 pi. Because 7 times 3 is 21. Okay, that makes sense. 24 pi, it's going to shrink down a little bit to 21 pi. 21 pi is, let's see, I have to use pi for that. 21 times 3.14 is 65.94. Okay, which is actually, because it wants us to round to the nearest whole number, that's actually closer to 66. Okay. And that would be inches squared. Now, if you try writing that answer in on Big Ideas, it's going to say you're wrong. And this is a tricky part of the problem that they don't tell you. Okay, but when I remove that piece of pie, or it looks like pie, when that piece of cheese, when I remove that slice of cheese, it actually adds 2 extra surfaces that were not there before. So with this piece of cheese gone, we actually have a rectangle that's now on the surface right there. You can see it's kind of yellow looking. And then we have a rectangle right here going the other direction. Those 2 rectangles are now on the surface. We have to include them as the surface area. Fortunately, it's pretty easy to find the area of those rectangles. The length of it is the radius 3, and then the width is 1. So 3 times 1 is 3, and 3 times 1 is 3. So yes, our answer is 7/8 as big, so we get 21 pi or 66 inches squared, but I have to add 6 onto that because of those 2 3s right there. And so that's going to make my surface area after the piece of cheese is removed 72 inches squared. So the last question says, did the surface area increase, decrease, or remain the same? Well, it decreased when I took the piece of cheese out, but not as much as you thought it was. Compare your 2 answers. We took 1/8 of the cheese away. We went from 75.4 to 72, because when we took the piece of cheese out, it created extra surfaces that we had to add back on. Okay, that's what made this problem tricky. Okay, let's look then at some more examples of surface area. I took these from your extra credit IXLs that are now posted on Google Classroom. So this first one here is asking you for the surface area of a rectangular prism. And it's from the AA .12 IXL. And so again, to find the surface area of a rectangular prism, I have a front and back side that are the same, a top and bottom side, and a right and left side that are the same. So let's start with the front and back. There's 2 of them. There's a front and a back. The dimensions of those rectangles are 2 by 3. I know that's got to be 3, right? 3 yards. So 2 times 3 is 6. And if you double that, that's going to give you 12. So the front and back are both 6, but together they make 12. Now let's do the right and left side. Okay, the dimensions of the right and left side are 9 by 3, but there's 2 of those. Nine times 3 is 27. 27 times 2 is 54. So 27 on the right, 27 on the left, 54 total. So I've got my right and the left side. I've got the front and the back side. That means I'm missing my top and bottom. The dimensions of the top rectangle are 2 by 9. The only two numbers I haven't used together. I've used 2 and 3 together. I've used 9 and 3 together. I have not used 9 and 2 together. 2 times 9 is 18. So 18 on top, 18 on bottom. That makes 36 altogether. And then the way I find my, so top and bottom, the way that I find my total surface area is I add those together. Okay, so a calculator here, that's going to be 12 plus 54 plus 36. And that should give us 102. And this is in yards, so yards squared. That's an example of how to do a rectangular prism. Now let's look at a triangular prism, which you might see a couple of those on this same IXL because they're prisms. This triangular prism has a triangle base on the front and a triangle base on the back. Now, what you may not like about these IXL pictures is they don't really show you what's going on behind the shape, right? But it should still be, right? Well, I'm not doing a very good job of drawing this. Right, it should look like that basically. Well, forgive me, I'm not doing a good job of drawing the back side of this this triangle. It goes all the way through. Yeah, maybe I'll just draw it like that. Anyways, I don't even need it because I know there's 2 triangle sides. There's on a triangular prism, the 2 bases are triangles, and because I know there's 2 of them, I can just multiply by 2. But remember, the triangular prism formula has a half in it because the area of a triangle we have to divide by 2 or take half. The base of the triangle is 12. The height of the triangle, it says, is 8. We're not going to use 10 as the height. And then remember how we talked about how when you work with the triangles, if you have 2 triangles, the 2 and the 1/2 cancel out, and you're really just doing 12 times 8, which is 96. So each triangle is 48, but together they make 96. So I've got both my triangle sides. Okay, I can get rid of all this. Now let's look at the rectangle sides. Did you notice that 2 of the sides on the triangle were the exact same? They don't look like they're the same because it's the perspective you're looking at it, but they are the same. This is an isosceles triangle, and what that means is that this rectangle here on the right side and the rectangle on the back side are going to be the exact same because those 2 sides are the same, and the length is 10 for both of them. So I have 2 sides that are the same. That doesn't always happen with triangular prisms. A lot of times you get a scalene triangle and they're all 3 different side lengths. But I've got a 10 by 10 side and I have 2 of them. So obviously 10 times 10 is 100. So 100 on the right side, 100 on the left side gives me 200 total. And then don't forget about your bottom rectangle, which is 12 by 10. I only have 1 of those. I have 1 12 by 10. You don't want to write the 1. You don't want to write the parentheses. You don't have to. 12 times 10 is 120. And so I've got 1, 2, 3, 4, 5. All 5 sides of my triangular prism. So I'm going to add them together like I did last time. 200 and 120 makes 320. Plus 96 is 416. And that's going to be meters squared. So there's an example of a triangular prism. On that same IXL, you might see some rectangular prisms that look like this. These are cubes, okay? These are cubes. And so it's a special type of rectangular prism, but it's a rectangular prism in which all sides are the same. So that's actually, this is the easiest shape that you could ever possibly take the surface area of, because all you have to do is find the area of one of those squares, and on a cube, all 6 sides of this rectangular prism, all 6 sides on that cube are the exact same. So I'm going to do 8 times 8 but there are 6 sides that are 8 times 8. So I don't have to do 2, 2, and 2 like I did the last rectangular prism. I can just do 8 times 8, which is 64, and times that by 6, and I'm going to get 384, and I am done. 384 meters squared. Finding the surface area of a cube is pretty neat. Very, very shortcut that we can use for that. A couple more examples. You saw this with the wheel of cheese. The wheel of cheese was an interesting one just because the piece of cheese was missing. Most of your cylinder questions on your 9.3 homework are going to look like this, right? They're not going to be a wheel of cheese. So let's look at it again. It wants us to round our answer to the nearest hundredth. You'll have to read the instructions because on your 9.3 homework, I think a lot of them want you to round to the nearest 10th, which is 1 decimal place. So we'll go ahead and do this one. So for cylinders, we only have 3 faces. We don't have 6 like a rectangular prism. We don't have 5 like a triangular prism. We have 3 faces here, 3. So I've got 2 circles. A lot of times the circles are on top and bottom, but they could also make the circles on the left and right side if they tilted it. It's fine, right? There's 2 circles. To find the area of a circle, you do pi times the radius squared, and the radius here is 3. Plus, now we're going to have this lateral rectangle that we get if we unrolled the cylinder, okay? To find the length of that rectangle, I have to find the distance around the circle. And the distance around the circle is called the circumference. And the circumference formula is pi times d, which is 6 for the diameter. So pi times 6. And of course, we know the height already is 10. So length times width. That's how I find the area of a rectangle. So 6 pi times 10. So the 2 formulas that I need to know to find the surface area of a cylinder, I need to know how to find the area of a circle, and I need to know how to find the circumference of a circle. Here's my circumference. Well, I guess I wrote it diameter first. Doesn't really matter, right? And then here's my area. So I have to know how to do the area, and I have to know how to do the circumference. I guess I could just write it. I wrote pi times 6 over here, so I'll just write pi. Oops, I'll write pi 6 like this. That way it makes more sense to you. Sorry about that. There's my circumference. There we go. All right, so let me get rid of this rectangle I drew. Let's go ahead and solve this. When I solve it, I like to wait until the very end to multiply by pi. I don't like to multiply by pi at the very beginning because then I'm working with decimals the whole time. So I'm going to do 3 squared, which is 9, and 9 times 2 is 18 pi. Remember, 3 squared is not 6. 3 squared is 9 times 2 is 18. On the other side, I've got 6 times 10, which is 60, and that's going to get times by pi. But I haven't multiplied by pi yet. I'm not going to do that until the very end. Even now, I can still combine the 18 and the 60, and 8, I'm not sure why I'm grabbing my calculator. That's just 78. So this whole cylinder is just 78 times pi. So now I will grab my calculator, and I will type in 78 times 3.14. If you're working on an iExcel, it does want you to use 3.14. If you're working on one of these extra credit ones, it does not want you to use the pi button. And 78 times 3.14 is 244.92. And that's square feet. Look how nice and neat that problem is. I have my 2 circle sides. I have my 1 rectangle side, length times width, okay? And so I just add those together to get 78 pi all together, and that's going to give me 244.92. Let's do one more. How could they possibly change the cylinder? Well, you can't change a cylinder. All cylinders look alike. They're the same shape. But maybe you can see in this one, they gave us the diameter instead of giving us the radius. So we have to use the radius when we're doing area. We have to use the diameter when we're doing circumference. So that's why we used 3 right there, and we used 6 right there, because the diameter was 6. This time, they're giving us the diameter from the get-go. So I have 2 circles, but the radius is only going to be half the diameter. So I'm going to use 4 for the radius. And then I've got my rectangle side. All right, if I unroll that rectangle, it's going to look kind of like that. It's going to be 4 tall. And then the length of that rectangle is the circumference. And circumference is pi times diameter, or just pi times 8. So circumference is how long that rectangle is. And then it's 4 tall. So my length is 8 pi. My width is 4. Okay. So I've got my rectangle and I've got my 2 circles. So I'm ready to start working on this one. Again, I'm going to wait till the very end to multiply by pi. 4 squared is 4 times 4, which is 16. 16 times 2 is 32. 8 times 4 is also 32. Interesting. The area of both circles combined is the same as the area of that rectangle side. 32 pi and 32 pi makes 64 pi. Now I'm ready to multiply by 3.14 to get 200.96 square feet. Look how nice and easy this problem is. It has 2 parts, the 2 circles, which gave us 32 pi, the 1 rectangle, which also gave us 32 pi, just a coincidence there. And I have my answer of 64 pi, which is 200.96 feet squared. Now, you'll have some questions on your 9.3 homework where instead of asking you to find the surface area, they're going to ask you to find the lateral area. Okay, we talked about that in class. The lateral area is just the area of the rectangle, not the 2 base circles. So if you get a question where it just says, what's the lateral area? You're shaving 2/3 of the work off the problem. If it says, what's the lateral area of the cylinder? It just wants you to do the rectangle part. So we just get 32 pi. And we obviously do 32 times 3.14. Okay. So if it just says lateral area, do not do the 2 circle sides. That's what you would do if it just says surface area. Let me know if you have any questions, and remember, get your homework done, and I'll see you guys tomorrow.